My name is Chuangyu Zhou. This is a video presentation for eDesign 496A final project. The software used to record this video is Cam Studio. It's an open source that can be downloaded from camstudio.org. The final project that I'm doing is using the parts that I made in the midterm project to make the suitcase assembly. This is just an overview of the project, and there are several moving parts in the assembly. One is the cover. It can be opened, and I made it with the base so that the angle of opening is limited. Also, the trolley can be pulled out, and you can see there are two parts on the trolley, and when I pull it out, the first part comes out and then the second part, but when I put it back, the first part goes back in first and then the second part. And the wheels can be moved as well. The other part that can be moved on the suitcase is the numbers on the number lock. For most part of the assembly, I used the parts that I made in the midterm project and applied bottom-up methodology. And also I made some new parts that is in context with assembly, so the top-down methodology is also used. This orange belt on top of the suitcase is an example of in-context design. I created this part in the assembly and I used the convert entity to create this part. So the dimensions of the belt is gonna change with the changing size of the suitcase, and also the size, the length, the height, and the width of the suitcase are linked with equations. So this is helpful when I need to make different sizes of suitcases. When I mated the parts to make the assembly, most of them are simple mates, and this is a limit angle mate that I used on the cover. And for the number lock, I used a width mate. I chose these two sides to be the boundaries and the sides of the number lock to be the tabs. So the number lock is right at the center of these two sides. Also, sub-assemblies are used in this assembly. One is the top handle bases mated with the top handle itself. So this is a sub-assembly, and also the number lock and those numbers are made into one sub-assembly. One of the parts that I applied finite elements method to analyze is the top handle. Since the suitcase is designed to hold stuff less than 50 pounds, I applied 50 pounds to the top handle, and this is the result that I got. The maximum stress is about 46 megapascal, and it stays way below the yield strength of the material. And also from the displacement plot, you can see that maximum deflection is about 2.3 millimeters, so that's not too much of a deflection, and the handle is pretty safe in this scenario. So this is my final project modeling the suitcase, and thank you for watching this video.